All right, today we started to cover some basic definitions of fluids and fluid characteristics, just to set the stage for our later analysis. First thing we talked about is what is a fluid. The basic characteristics of a fluid is one that, when acted on by a shear force or a shear stress, it continuously deforms. And so if I think of some time delta t after the start of applying this force, the volume deforms, and it continues to deform as time proceeds. I'll get better with these arrows, I promise. So here's delta t. And then this goes on for all time as it continuously deforms under the action of this shear force. We then talked about intensive and extensive properties. Intensive properties are things like density and temperature and velocity that are defined at a point. One way to think of this is if you have a volume of fluid which has a density, say, rho, and a volume v. By the way, I'll denote volumes as v with a cross through it, a slash through it, in order to distinguish it from velocity. If I now take that volume and double it, like so, it could continue to have density rho, but now the volume is 2 times v. The black box has a particular mass, whereas the red box has mass which is 2 times m. And so the distinction here between the intensive property, rho, and the extensive property, mass, so rho being the intensive property, does not change as you change the volume, whereas the mass does depend on the total volume, and that's the distinction between intensive properties and extensive properties. It's important to keep these straight when you're analyzing problems. You don't want to mix them. For one thing, the units on your solution will be wrong, but further, it's really describing two different components. Other examples of intensive and extensive properties include temperature as an intensive property, heat content as an extensive property, or velocity and momentum, as we talked about in lecture. Finally, just note that we defined pressure as the normal force per area, and the shear stress as the shear force per area. So shear stress is tau. We'll denote that as tau. That'll actually end up being at times a tensor instead of just a number. But that's going to be the shear force per area. Okay. Again, just definitions for now. Important to have a common language that we can work with as we go along the semester. Last thing I'll note is for Monday, I would like you to view video number 16 of the Everyday Fluids. And I will write Everyday Fluids if I have space. Everyday Fluids playlist. Video number 16 relates to viscosity. Have a good weekend. We'll see you on Monday.